10.1, identify quadratic functions and their graphs. Our objectives in this lesson are to determine the direction of opening of a quadratic function, which means does it open up or down, determine the vertex, axis of symmetry, and intercepts of a parabola given its graph, and find the minimum or maximum value and the domain and range of a quadratic function from its graph. First, let's talk about what a quadratic function is. Quadratic function is a function that comes in one of these two forms: f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. Now, when it's written in this form, that's its standard form. It may look different than that, right? So it might be something like x squared plus y equals 5. Even though it's not written in its standard form, it's still a quadratic function. So what's determining the quadratic here is, of course, a degree of 2. So any function with a degree of 2 is going to be a quadratic function. Now, the graph of a quadratic function is always going to be a shape called a parabola. A parabola is kind of like an arch. It looks like that. The example they give in the textbook is a fountain. When water sprays up out of a fountain, it always sprays in a parabola shape. Okay, first let's talk about, does the parabola open up or down? So if you're given a quadratic function, let's take the one I gave before, x squared plus y equals 5. We know it's a quadratic function because it has a degree of 2. And so to work with this function, we're first going to put it into that standard form. Standard form means we have y on one side and we have all of our other values on the other side. So I'm going to go ahead and just move over my x squared to the other side and arrange everything in standard form, and I have negative x squared plus 5. Now I have to decide by looking at this, does my parabola open up or down? The way we decide that is we look at our a value. So remember, standard form is y equals ax squared plus bx plus c. Looking at the one I have here, my a value is my negative 1 here. My b value is going to be 0 in the one up here because there is no single x. And then my c value is my 5, right? So when I identify my a value, let me just make a little space over here. Once I identify my a value, I look at if it is greater or less than 0. An a that is greater than 0, basically positive, is going to open upward. The parabola of that graph will open upward. If a is less than 0, or basically negative, the parabola is going to open downward. So for my graph here, y equals negative x squared plus 5, I'm going to have a parabola that opens down. Next, let's talk about how to determine the vertex and the minimum or maximum values from a graph. The vertex is where a parabola changes direction. So for example, with this parabola, it's going up, 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 and then at some point it changes direction and starts going down. So the point where it changes direction is what we identify as the vertex. If you have a downward opening parabola, like the one we have here, where it opens down, the vertex is going to be the maximum value. So in a parabola that opens down, we have our vertex as our maximum value, and we don't have a minimum value. If you have a parabola that opens up, so let's draw another parabola here. So this parabola opens up. It's not perfect, but I do my best. And let's say the vertex is here. Then the vertex of a parabola that opens up is going to be the minimum point. So an up opening parabola, it's their vertex. Okay, so how do we assign values then to these points? So for the vertexes, all we have to do is read that point off of the graph, the xy coordinates. So if we look at our red parabola first, the coordinates of that are going to be an x of 1, 2, 3, 4, 5, 6, and a y of 1, 2, 3, 4, 5. So your vertex point is 6, 5. Your maximum value is going to be the y value of that coordinate. Okay, so your maximum value is as far up as it goes, the y value of 5. At our other parabola, the upward facing parabola here, we're going to identify our vertex first. It has an x of 1 and a y of negative 1, 2, 3, 4, 5. So we have 1, negative 5 for our vertex. And then for the minimum, we once again take the y value of that vertex point and say the minimum is negative 5. All right, how about domain and range? If you're given the graph of a parabola, you can identify its domain and range. For any parabola, the domain is going to be the set of all real numbers. Ooh, let me fix this here. So remember, we use our braces here, and then you can just write all real numbers on the inside. The range, we're going to use our braces again, is going to be the set of y such that it's either going to be greater than or less than the vertex. So depending on if you have a maximum or a minimum, let's say our vertex is at 1, 2, 3, 4, 5, 6, 7. Let's place it at y equals 7 for our vertex, our maximum point. So the range then is all values of y less than or equal to 7. If we had a parabola that opened the other way, let's do one in red here. Okay, and we would find a vertex. It's not exactly on the line, so we might have to estimate here. Negative 1, 2, 3, 4, and a little bit over, so let's call the minimum point negative 4.3. So then our domain and range, domain once again is going to be all real numbers. Close the set. The range is going to be the set of y such that y is greater than or equal to negative 4.3. Next, let's talk about the axis of symmetry. The axis of symmetry is the line along which, if you folded the parabola in half, it would be, a complete mirror image. It would perfectly fold in half. So the middle line, or you could cut the parabola in half, is called the axis of symmetry. And if we would like to write an equation for the axis of symmetry, we first have to find the vertex, and we have to identify the vertex, which in this case it's an x value of 0 and a y value of 1, 2, 3, 4, 5, 6, 7, 8. There we go. And we want to give the equation of this green axis of symmetry line, which is just going to be x equals the x value from our vertex here. So in this case, it's x equals 0. You could have another parabola that was something like that, where your vertex lies right here along the x value of 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so if you have a vertex of 9, 1, 2, 3, 4, 5, let's call it 5.8, then your axis of symmetry is going to be along that x value, x equals 9. And finally, let's talk about x-intercepts. An x-intercept is where the graph of your parabola crosses the x-axis. You can have 2 intercepts. You can have only 1 intercept if it's just touching there, or you can have 0. So the parabola does not necessarily have to touch the x-axis. So if we have a graph, to name these intercepts, we merely read the points off of the graph. We might have to estimate a little bit here. Let's do our best. We've got 1, 2, 3, 4. It looks like negative 4.5. And of course, the y value is going to be 0. And for the other intercept, we have 1, 2, 3. Let's call it 3.25. And a y value of 0. Down for my green one, looks like we have an x-intercept of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like 10.5 for the x value, and of course a y value of 0. And then for the red one, we have no x-intercept. If you want to see more examples of these, there are a lot of great pictures in the textbook. I encourage you to look at them. For your try these, go ahead and do numbers 1 through 8.